Hi guys, today we'll be discussing another trick how to find range of a function. Now this trick is applicable only to a specific type of a problem, but still it will save a lot of time. So let's see how. Now we need to find range of these functions. Now all these functions are of the nature px by qx. Okay, so let me just quickly write the range of all these functions. So the range of the first question will be r. Range of the second one is also r. Range of the third is also r, and fourth is also r. R means real numbers. So you want to know how? Let's see. So the trick is, whenever the function is of the type x minus a, x minus c upon x minus b, where b lies between a and c, then the range of the function will always be r. So this is the trick that we have applied here. Let's look at the first example again. If you notice here, the first function a is equal to 1, b is equal to 2, and c is equal to 3. Since b lies between a and c, therefore the range should be r. Similarly here, if you notice, the a value is equal to 2, c value is equal to 6, and b value is equal to 4. Since again b lies between a and c, therefore the range is again r. Similarly here, nothing is written, so I will write x minus 0 here. So this is a equal to minus 1, c will be equal to 3, and b will be equal to 0. So therefore again the range will be r. Similarly in the fourth one, a is equal to minus 2, here c will be equal to 7, and b will be equal to 1. Therefore again, since b lies between a and c, therefore the range is r. Now in the first example, we have taken the function as x minus 1, x minus 3 upon x minus 2. Let me plot the graph of this. Now in order to plot the graph of this, let's see what all information is already provided to us. By observation, we can see that at x equal to 1 and x equal to 3, y will always be 0. So the graph should pass through these 2 points. Also, we notice that at x equal to 2, there will be a vertical asymptote. Vertical asymptote is a tangent to the curve at infinity. Means this graph will never touch the line x equal to 2. Let's use this information to plot the graph. X equal to 2, I am showing by dotted line. Let me plot the roots also, 1 and 3 here. So the graph should pass through this point and this point, and it should never touch this line x equal to 2. What else we know? Let's find out. At x equal to 0, y will be equal to, let me put 0 here, 0 minus 1, 0 minus 3 upon 0 minus 2. So therefore we will get minus 3 by 2. So therefore we got another point here, 0 comma minus 3 by 2. The graph should pass through this point also. What else? Rest information we can find out by differentiation. Our function was x minus 1, x minus 3 upon x minus 2. If I multiply these two brackets, we will get something like this. If I differentiate this dy by dx, then applying quotient rule, I will write x minus 2 into 2x minus 4 minus x square minus 4x plus 3 into 1 whole divided by x minus 2 whole square. Then let's take 2 common here. So I will get x minus 2 whole square minus x square minus 4x plus 3 inside the bracket divided by x minus 2 whole square. This, if I open the bracket, I will write x square minus 4x plus 4 minus x square plus 4x minus 3 whole divided by x minus 2 whole square. So we will get x square. This is 2 into minus 4 minus 8, and then plus 4, so minus 4x. And then we have 2 into 4 here, 8 minus 3. So therefore we will get plus 5 whole divided by x minus 2 whole square. Now notice here that the denominator is always positive. Denominator is always positive. What about numerator? For the numerator, we observe that the coefficient of x square is 1. And let's check the discriminant of this. Discriminant is b square minus 4ac. So discriminant for this function will be equal to minus 4 whole square minus 4 1 into 5. So you'll get 16 minus 20, which is less than 0. So for x square minus 4x plus 5, we observe that here coefficient of x square is positive and discriminant is less than 0. Therefore this function x square minus 4x plus 5 is always positive. This we have studied in quadratic equation chapter. For any quadratic equation, if a is greater than 0 and d is negative, then this function is always positive for all x belonging to R. So applying this logic, let's go back again to the differentiation. So we got this as the differentiation. We already saw that the denominator is positive because it's a perfect square, and by this logic of quadratic equation we know that numerator is also positive. Therefore f dash x is always positive. This implies that f is strictly increasing function. So let's utilize all this information to plot the graph of the function. So we have already plotted part of it. Now let's join all the dots. So we know that the graph should pass through 0, minus 3 by 2, and it should be an increasing function. So it should go like this. It should pass through 1, 0, and it should continue to rise. Similarly on this side, at x equal to 2 there is a vertical asymptote, so it should never touch the line. So the graph should be like this. So that will be the graph of the function. Now if I ask you what will be the range, so range will be R here, because we see that all possible values of y are acceptable. So the reason behind our trick is here b should be between a and c, and whenever this happens, the graph of this function will always look something like this. And if the graph is like this, always the range will be R. So that's why we can generalize this and use it in the questions directly. Now is the time for DIY. I want you to plot the graph of the function given and see if the range of the function is R or not. You can also use scientific calculator to plot the graph. Please write the answers in the comment section, and if you like the video, please like and subscribe the channel, and don't forget to press the bell icon, and stay safe and stay healthy.